Coming up, I have a Luxman L230. This is a 63 watt per channel integrated amplifier from the early 1980s, I'm going to say. This one here was brought to me by a client. He just wants me to check it over. We know the input selector lights are shot, so we're going to take care of that. But he also noticed that there looked like there was some components that have been getting hot inside, so he wanted me to check that out, make sure something's not going to go boom on it in the near future, because he might want to sell this one. Today I have a Luxman. This one's, what is this model? An L230 amplifier, integrated amplifier in. This one works. No problem with the amp. What the problem with this one is that the indicator lights are all out. So the owner of it would like me to check and see if we can get new lights and make the indicators work. So let's pull this one apart and take a look at what type of job this is going to be to change the indicator lights. Top comes off. Looks like the lights themselves are just stuck in the front. And this one should be a relatively easy one to just pop new lights in. Excellent. Well, this one is going to be pretty simple because the indicator lights are just stuck in the back here. And this one even has a green cover over it. And this one has a white cover over it. And this one here has no cover over it. 3 different colored lights. Okay. They're just going to be incandescent bulbs. So we're going to measure the voltage and see what type of what voltage I need. And then looks like someone just replaced these ones in the past. Usually those lamp condoms, is what you used to call them, would break when you tried to take them off the lamp. But in this case, I'm able to save 2 of them, the yellow and the green. Someone just replaced these with regular panel type bulbs and soldered the wires on. I mean, you could do that. There's nothing wrong with doing that if you don't have the ones with wires already on them, which I don't, but you never know, because I get to these. I tried to get this one early in the day so that I could head out and get some new bulbs if necessary. When I step out for lunch, I will make a trip into the electronics shop and see if we can get some replacement bulbs. First though, we need to know what voltage the bulbs are, so we'll just measure that and see. So power is on. Let's just measure. I'm on the auxiliary input, so let's just measure ground to auxiliary. I got nothing. No AC or DC voltage. So maybe the lamps have not failed. Maybe the lamps are just fine. Maybe it's a problem somewhere else in the amplifier. Okay, that bulb's now working. So what the heck? Is that a switch problem? What's the voltage on the bulb? 28 volts DC. These are big bulbs. Which one's that? That one's on auxiliary. So let's go to tuner. This is the bulb that's on tuner. Has it got any voltage on it? 45 volts. Wow. These are big bulbs. So that bulb's blown, but this bulb is okay. What about this one? What about the phono bulb? Right now there should be nothing on here, which there isn't. If I change to phono, where's that phono? Yeah, so 28 volt bulb. Yeah, these are 28 volt bulbs running at 27 point. Under no load, I've got the full power supply across there, but yeah, 28 volts, 27.9. Quick search of the local shop website, and I find that he has 28 volt bulbs in stock, so I'm going to be doing that today. I'm going to go down and get 3 new 28 volt bulbs. A couple different sizes available. I'll take the one down as a sample just so I get the right size. A trip into the electronics shop to get 3 new bulbs. We're going to replace all of them. So this one here is still working. I'm going to take this one out and just keep it as a spare because it doesn't even look like it's got many hours on it, so I'll hang on to that one. That one was in the auxiliary. I think that was auxiliary. No, that was the auxiliary. So the tuner and the phono were the ones that were burned out, probably the ones that got the most number of hours. Anyway, here's a new bulb. So there's that bulb lighting up. So we're going to replace the 3 bulbs and get this thing working like new. I solder the center one on first just so that it'll support the lamp so I don't burn myself when I heat the edge up, the case up, to solder the other wire on. Otherwise I have to have something to hold the bulb, right? So this way I can use the wire that's supporting the lamp to hold it in position while I attach the other wire. So there's one done. And we'll do the other ones. Okay. I guess we'll put the 2 different colors on, so it'll be 3 different colors, because this one's kind of a yellow, an off-white, so I'll have a green, a yellow, and a clear lamp. I'll put this one here over the, I guess this was the, which one was this? This is the auxiliary. Maybe we'll put that one over the tuner, which is the bottom bulb. And we'll put this one over the auxiliary. Which is the middle bulb. And then put the top one in without anything. So we have 3 different colors of bulbs. So here's how it looks now. It does affect the brightness of it too. That one's white color. Where are we here? Green and tuner. I don't know how it shows up on camera, but that one's a little more of a yellow, not quite as bright. Same with the green. This one, because it has no filter on it, is brighter. But now the 3 lights light up as they should, and they do have 3 distinct different colors. Like all quality amplifiers, it has a removable bottom cover. Slips off just like that. This amplifier uses 2SE3181 and 2SA1264. These are just standard bipolar junction transistors. They cross over to NTE or ECG. 36 and 37, those are the complementary, and the specifications on these transistors are as follows, and they can actually dissipate 100 watts and have an operational temperature of up to 150 degrees Celsius. The collector current can handle 12 amps continuous and 15 amps peak. So these transistors are good, solid, powerful transistors that you're unlikely to blow because the power supply itself won't have enough power available to deliver 100 watts out of these. I think this amplifier is only rated at, I think it's 60 or 65 watts per channel. But it's not, as to say, they tended to underrate their amps as far as how they built them as far as power goes. Luxman were always good in that respect. Again, they're bipolar junction, BJT, bipolar junction transistors, not MOSFETs. Some of the amplifiers, like my hybrid LV103, for example, uses MOSFET outputs for the 2 solid-state devices per channel, plus the 2 vacuum tubes. This one doesn't do that. This one here, it's bipolar junction transistors, which is good in a way because the components themselves are still readily available. Unfortunately, the MOSFETs used in the LV103 and the LV105 are obsolete, and good luck trying to find replacements, because they'll be very difficult indeed to try to find anything that will replace them. Similar to the LV103 and LV105, these ones have LEDs on here that indicate that their bias is operating correctly and that the amplifier is operating. So this is why we always inspect the bottom of amplifiers for connections that will fail over time just due to heat. Like this one, for example, here. If I wiggle the resistor on the top side of the board, you'll see that it moves. You can see that? So that's an obvious future failure point. So when doing maintenance on any amplifier for any reason, it's always a good idea just to pop the bottom off of it, just to inspect, make sure that there are no connections that are failing just due to stress from heat and cooling, right? This is what happens is over the years, just from the constant heating and cooling. This is a Zener diode here, and they have a tendency to get a bit warm. So from the heating and cooling over the years, heat stressed connections can occur. So it's a good idea just to go through, inspect, and reflow as necessary. This will prevent future problems. Zener actually failed, and it actually had broken. So when we reheated it, obviously it just came right apart. So I got to look that up and replace it, find out what value it is and replace it. The Zener diode that failed is not really critical. It's right here. And I have a helper coming to visit me. My Siamese cat has come to visit me. HRD112. It's a 22 volt Zener, and what it does is because it's feeding off the minus 40 volt supply right here, and through this resistor, and it's filtered by this capacitor. And what it does is, if we follow it up here, you'll find that it goes to the pilot lights right there. So what that Zener diode does is it limits the voltage to 22 volts. These are 28 volt bulbs, if you remember, the ones we just replaced. Normally the load from the lamp is going to keep that voltage down, and it does. When the lamp is running, we're measuring about 28 volts because everything's getting pulled through this 270 ohm 3 watt resistor, which is one of the ones that's been a bit warm here on the back. That would be, which one is it? Probably this big one back here. Probably this big one back here that's warm. What's the number of it? It's R153. I'm sure that's what that one is. Yes, it is R153. So the 48 volt supply is pulled through this resistor, and its voltage is limited by that Zener diode right there that's broken, and that's what limits the voltage to the light bulbs. Under normal operation, the lamps themselves are going to be drawing the bulk of the current through this resistor. The Zener diode is not doing much. It's just keeping the voltage in check at 22 volts, which will of course extend the life of a 28 volt lamp by keeping it operating at 22 volts. Now what happens though is when the light bulb burns out, now there's no load. Now all the current that resistor is capable of passing is now going through the Zener diode, which of course overheats the Zener diode, and then over time the Zener diode opens. And that's why when we were testing the lamp voltage before, when I put the meter across one that was open, I had like 36 volts or so, and then when I put it across a lamp that was working, it was down at 28. That's the reason that Zener here, this one, is open. So let's find a 22 volt Zener or even a 24 volt Zener. For that matter, it can be anything less than 28 volts because the lamps are rated at 28. We'll find a new Zener, we'll replace it, and at least that way it'll keep the lamps running at a lower than their rated voltage. Therefore, the lamps should run forever, or for an awful long time. So if you want to test unknown values of Zeners, you can make up a little circuit. You need a resistor. In this case, I'm using about 560 ohms, I guess. It doesn't matter, but a resistor, variable power supply, and your meter across the actual Zener. And what will happen is, as I increase the voltage, this is a 22 volt Zener that I've got here. I know it's a 22 because I looked it up, but I have some that the numbers aren't even visible on. So my power supply is now sitting at 17 volts. Where's my meter leads here? Put the meter across the diode, the Zener in question. We'll see 17 volts. As I increase my power supply voltage, it's going to stop at 22 because it's a 22 volt Zener. So as I increase my power supply voltage, okay, I'm at 26, 27 volts, 28 volts now. The Zener is 22 volts. So we know that this one that I've got here is a suitable candidate to replace. But if I didn't know the value of this one, I could just grab any other Zener that I've got in the pile, the ones that the numbers and stuff that have worn off, and I can test them the same way and find a suitable replacement if I didn't have one that had numbering on it that I could look up, because I have a big box of diodes here, lots of Zener diodes in here that the labeling is no good. I think the guy that got these probably got them at the bargain bin at Radio Shack that gave them to me. So lots of Zener diodes, which I don't know what the value of them is. So I can test them, see what value this one here is, for example. This one here is that one may not even be a Zener. That one may be just a regular diode, because of course we're reverse biasing it so it'll never turn on. But that's why if you've got some Zeners that you don't know, you can always find them out that way. Here's another one, for example. The numbering on it is unknown. I know it's a Zener, but I can't read the numbers because the numbers are worn off. So I connect it up to my little test jig here, the way I did before. And crank up the voltage. It's a cat doing something it's not supposed to. I can hear it in the background. Okay, as we see here. This is another 22 volt Zener. Get the voltage at 27 volts now. So this is another one that I could use. Power supply is cranked up to 32. It's holding at 22.4. So this is another good one that I could use. So that's just an easy little jig that you can make up. And if you get the Zener, if you hook it in backwards, okay, all that's going to happen, it's not going to hurt it. If you're clipping it in and you clip it in backwards, it's just going to act like a regular diode, and you'll have 0.8. Current's not going to go through it because the resistor is going to limit the current. So you don't have to worry about damaging them. Just make sure you have a current limit on your power supply, and then go to it. You can test your Zener diodes if you don't know what you've got. As I say, some of the ones in here that I've got, they've got numbers on them, but the numbers themselves are very hard to read. They've been sitting. This one here, the band isn't even showing on this one. Is this really a diode? I guess I'll find out. As I say, I got given this big box of diodes of all different types, and every so often when I need one, I can find them. Like this, it looks like some detectors in here, right? Some glass. These are probably germanium, I think. And these, whatever these ones here are, I got all kinds of little weird different numbers and different styles of diodes. Someone was making a bridge of some type out of this. This one here, this is a 9 volt Zener, that one I believe. But yeah, I got a bunch of them. So anyway, if you don't know, that's how you can find it out. We can test it. So we'll remove the dead Zener. And unlike the first one, I'm going to leave this one spaced off the board a bit just so that it can dissipate some heat. Zener diode should always be left a little bit off the board just because they are going to get warm. Good practice when you're dealing with any components that produce excessive heat. Zener diodes, large current limiting resistors, for example. It's always a good idea just to leave them off the board. Okay, now we can check it out. We'll see only 22 volts at the light bulbs. Okay, here we go. 23 volts. Close enough. Close enough. When I switch to the phono input, 23 volts. And when I switch to the auxiliary input, we have 23 volts. So that will definitely extend the life of the lamps. And I always advise, if you're putting a metal bottom on something, turn off the power first, just in case something, you slip. I've seen it happen. It hasn't happened to me, but I certainly have seen it happen before, where someone's putting a bottom on or taking a bottom off, and the chassis is energized, and they slip, and then there's a big pop, usually followed by a bunch of swearing. Never saw that happen at the shop I worked at. Actually, I did. More than one occasion. Usually a pop or a snap, or followed by an oh crap or an F-bomb. And then usually the owner, he'd hear something, or he'd smell something burning. He'd come in the back to find out what just got blown up. Usually he would start yelling and stomping his feet and yelling at somebody because it just cost him money. Needless to say, we got a good laugh one time when the boss came in the back and he broke a picture tube. Of course, it wasn't his fault, it was our fault, because the TV had been left in a vulnerable position. It had been taken off the bench and put on the ground without the back on it. And what was the reason for that? Well, that's because the boss came into the back with a rush job for a customer. I think it was if I remember correctly, it was a VCR or something that, pretty sure it was a VCR that I had just cleaned it, and the customer took it home and put the same tape in that they had put in before that had clogged up the heads, which clogged up the heads again, and they came back yelling. So it was like one of these, come in the back with the set, and here, you gotta do this right away. So I took a TV that was sitting on my bench all apart, and I put it down on the floor so that I could work on this machine, so I could take it apart and clean the heads again. And the boss came in the back and wasn't paying attention, and his pant leg caught the little circuit board on the back of the picture tube, and all of a sudden we did hear this, and then the fit hit the shan because the boss didn't want to pay for a picture tube. He felt that that we should be the ones eating the cost because he was clumsy and broke it. In the end, he ended up eating it because I told him that there wasn't a snowball's chance in hell that I was going to pay for something that he broke, and threatened to quit. Okay, power on. And the tone controls on here somewhere, I think. Oh yeah, tone control. Tone controls are on now. You know, I've never had an amplifier until I got my first Luxman that I actually enjoyed listening to it flat without adding any bass and treble. But my first Luxman that I've got, my LV130, which is now kind of in semi-retirement because I've replaced it with an SUV9. But it was the first amp that I got that I actually enjoyed the sound best when the tone control was set to defeat. And this one's another one that just has a really nice sound, even with these small speakers I've got in here. Before I take off, here's the lights. That one's got the yellow filter, that one's got the green filter, and that one has no filter. And yes, it is brighter. Yellow, green, and white. But at least now it looks like it's supposed to, with lights that are lighting up. That increases the resale value when the lights work. Thanks for watching.